Perfect. So good morning, good afternoon, or good evening, everybody. And thank you for joining our webinar. Thank you, Federica, for the introduction. And as Federica said, I'm Alessandro. I'm a technical market engineer for the data center and provider connectivity group. Today, I will be presenting to you the latest episode we have around the Nexus Dashboard Fabric Controller series. It's time now to talk a little bit about automation and automation in the context of NDFC. Why is it important? Well, there are many benefits that we can all get with automation. And today, my goal will be to tell you a little bit what are all the possible use cases that you could implement for your data center networking architectures, for your data center fabrics controlled by NDFC. In order to do this, in order to be able to provide you some sort of guidance, in order to be able to provide you some sort of inspiration on the different use cases that you could implement, I will need first to review why automation is important. Then I will have to explain what are the possible use cases that you can implement and what are the possible interfaces that you can use in order to interact with NDFC in a programmable way. We will try to understand what are the existing tools that will allow you to do so. And we will also cover this with some demos using different technologies. Now, like I said, this is mostly to get you inspired. We have 90 minutes ahead of us, and that should be enough to cover at least the basics. Then hopefully some of the use cases I will show you are going to be relevant for you, but as well, try to understand the basics, try to think what are your use cases that you would like to automate, and build them starting from the basics that we are going to cover today. Agenda, very quick. We will start with an introduction on the automation and the benefits of automation. We will talk about the Nexus Dashboard APIs, which also include as well the Nexus Dashboard Fabric Controller APIs, because that is going to be the base for all the upcoming discussions. At this point, we will move to the section about the integration between NDFC and Ansible. And finally, I would like to close by telling you a little bit something around the Vxlan S code, which is a new module for the network as code automation framework that Cisco is delivering. Let's start with the introduction. We constantly talk about automation, right? Why do we talk about automation? Because automation is very important. Automation can bring us many benefits. You see the most important ones here. We talk about increased efficiency. Why? Because automation allows us to save so much time on the routine operations, on the most basic day-to-day operations and tasks that we have to do in our daily jobs. By saving the time on those phases, by automating those phases with some sort of automated workflows, we can recover precious hours, precious days that we can invest somewhere else. And this is about getting more resources. When we talk about more resources, it could be time that we can reinvest in other tasks that we normally leave behind. For example, let's study a new functionality. Let's review our design, or let's review the documentation. Those are normally the things that we leave behind because we do not have time. And thanks to automation, we will be able to get some of this time back for these tasks. We also talk about reducing risks. Why? Because using an automated workflow allows us to deliver a predictable configuration into our environments. Now, we know that when we have predictable configurations, when we have standardized configurations, everything is going to work as we expect. If we start having drifts into the configuration, that is the moment where we will have some problems. It's also about including additional tasks together with the configuration automation workflows. Imagine you also want to introduce some sort of validation, some sort of testing after the changes implemented with automation. That is where you can get all the benefits around the risk reduction that will provide you a better user quality, a better quality for your services, for your applications, and so on. And finally, we talk about accelerate business, because automated workflows can span across multiple technologies and can help us provision the entire feature set we need for a new service, for a new application, and so on. One of the most common urban legends around automation, but luckily I hear this less and less, is the following one. I can't advantage from automation because I'm not a software developer. And this quote is coming, in this case, from Cody Puckett, right? A fictional character. But I've heard this also coming from customers and partners speaking with them. My answer every time I hear this kind of quote of statement is the following one. That is absolutely false. Whatever you are a developer or not, you can still implement automated processes. And this is what I want to show you today, because today we are going to cover 3 different macro areas around automation options. We will start by looking as well at some direct API interaction, which requires some sort of coding experience. And then we're going to uncover 2 more methods, Ansible and Vxlan as a code. Each of them is going to abstract the complexities of coding, of writing scripts more and more. That is going to be in order to prove you that definitely you do not need to be a developer, you do not need to know or have any coding skills in order to implement automated processes. Now, all this webinar is going to be around Nexus Dashboard Fabric Controller, obviously. We know that the Fabric Controller has 3 main core functionalities. Management, which allows us to define our intent, right? Intent for our fabrics, for our overlays, and so on. We have some visibility, some basic visibility that provides us insights on the status of these fabrics. And we also have automation. But when we talk about the automation core functionality, we really mean the NDFC native automation capabilities. So the ones that allow NDFC to read the intent that the administrator is setting on the controller and transform that, render that into real configurations that can be sent to the devices and can be transformed into running configuration onto them. But today I want to talk about something else. I want to talk about the additional automation capabilities that are exposed by NDFC via the APIs and that can be used in order to implement different use cases. Now, let's try to understand what are the most common use cases, and then we're going to see how we can achieve them. First of all, standardized deployment processes. Now, we talk about avoiding the manual clicking, the web UI use in order to configure our networks. Why is this important? Because if we use an automated process, and let's keep it at very high level as of now, let's call it just automated process, we can ensure that every time the script, the automated process will run, it will return to us a predictable outcome, a predictable configuration. And that means having standard configurations. It could be that if we do things manually, we forget about enabling a checkbox. We forget about a specific thing that we should every time do because it was part of our testing plan. And that is going to create problems into the future, maybe. With an automated process, we can avoid all this. We can also talk about importing data from external resources. Imagine in the context of NDFC, you want to push networks, you want to push subnets, you want to push VLAN IDs, but these resources are stored somewhere else. Maybe an IP address management system. Like in this case, I'm talking about Netbox, which is a very powerful one. Why do we have this use case? Well, because you do not control only data center networks. You control other network domains as well, campus, WAN, branch offices, and so on, right? And you want a central database, a central tool that can keep all this information. So in your case, you will enter the information into the IPAM, and then you will have the automated process reading the information from the IPAM and render the configurations, the intent that is going to be pushed to NDFC automatically. And this is also something that we are going to see during the demo. We can talk about integrating additional applications. It's not only about automating NDFC. When we create a new network, when we create a new VRF, we always know that that network definitely has to be available on our data center fabric, but it has also to be stretched outside of it. So we can attach endpoints, we can attach VMs, we can attach firewalls. With automation, we can integrate different applications. We can manage all of them. We can push configurations to all of them to ensure that we have an end-to-end path, let's say, an end-to-end configuration that is going to span across all of them, and it will allow us to push the networks wherever they are required. We can talk as well about infrastructure as code, which gives us the possibility to define the entire networking infrastructure configuration in an easy to read, easy to write file. File can be encoded in different formats. We are going to see an example with the Vxlan as a code. But the important thing is that the same file can also be processed by the automation process, right? So it can read it, it can understand it, and it can transform it into the real configuration that is going to be pushed into the devices. And we're going to talk about the different benefits into the Vxlan as a code section. And last but not least, think about the automation pipelines. Automation pipelines are a set of heterogeneous automated tasks that we can define for our automated workflows. They can include tasks that are going to push the configurations. They can include tasks that are going to perform initial validations, tasks that are going to perform post-change validations. All of them can be part of our day-to-day workflows that we want to use when implementing new networks, new services, new applications. Like I was saying before, the ones we just covered, are just the high level of the different use cases we can achieve, right, with NDFC additional automation. How can we interact with NDFC? Now, I will provide you 3 general options. The first one is the direct API interaction. And obviously, I consider this probably the most difficult one. Why? Because first of all, it requires API knowledge. And when I say API knowledge, I mean you need to know the different API calls that you can make towards NDFC. That requires some study. Second, in order to interact with APIs, you also need the proper tools like API testing tools, or better, you need some sort of scripts, some sort of programming languages that will allow you to play around with sending data and receiving data from the APIs. Obviously, there are pros and cons for this direct API interaction. Pros, definitely, you have the full functionality set available to you. All the APIs that is used by the application can also be used by your scripts, by your code, let's say. You can integrate with any other application, because most of the times, if we think about high-level languages like Python, those high-level languages offer libraries to integrate with any kind of application, with any kind of architecture. So reading data from one side, pushing the data to the other side, talking about applications, is going to be very easy. And obviously, you can manipulate the data as you want. You can play the data as you want. You can do pretty much whatever you want. The possibilities are going to be infinite. The cons, like we were saying before, definitely you need to understand the APIs. You need to know what APIs are available. You need to be able to write some sort of code. You need to understand at least the basics of coding. I'm not saying you need to be a software developer. Definitely, I'm not a software developer, but at least I'm able to understand a little bit how to handle the code that allows me to interact with the different applications, with the different systems. And last thing, it's not good, definitely, in case you are just starting with NDFC, because you will not be able to understand what are the basics of the operational model that NDFC is offering. The next section, the next option, is going to be around automation tools. What are automation tools? Well, those are binaries, are softwares that are written by other companies, by other people, that allows us to introduce automated workflows into our networks because they are flexible, because they can be expanded with additional modules that allows us to interact with different tools, with different applications. As of today, Ansible and Terraform are probably the most 2 commons, but I already want to do a distinction at this point of the webinar. When we talk about Ansible, we have an Ansible collection available that contains a lot of modules that allow you to interact with pretty much all the functionalities available in NDFC. And we are going to cover that later on. When we talk about Terraform instead, there is a Terraform provider available for NDFC. That is not something that we have, by we, I mean Cisco. That is not something that we have created. It's not something that we are currently maintaining. We only did a couple of pull requests into this repository. And to be honest, it doesn't offer the same feature parity as Ansible. That's the reason why I've excluded it from this webinar, because the possibilities that we have compared to Ansible are quite limited. So now, what are the pros about using an automation tool? Like in this case, you see here, right into this slide, an Ansible playbook. First of all, we are abstracting all the complexities of the code. There is no need to know anymore how to code. There is no need to know how to keep track of the variables, eventually how to define the loops and so on, even though we still have the possibility to implement this into Ansible if we really need. But if we don't care about that, that's fine. We can still use static playbooks and everything is going to work fine. Additional pros for Ansible, definitely the integration, because Ansible is a well-known tool and has modules to interact with all the different applications, especially into the data center world, into the data center portfolio. Now, definitely, if you want to move over this direction, you still need to do some sort of upskilling, some sort of learning. You cannot expect to install Ansible and be able to use it in 5 minutes. I would say it takes a few hours at least to get some sort of basic understanding and start defining the playbooks, which we are going to see in a little bit, start managing the different configurations through the playbooks and so on. If we want to abstract things even more, at this point, we have to talk about Vxlan as code, which is an additional module part of the Cisco network as a code. At this point, we do not care about coding anymore. We do not care about loops. We do not care about variables anymore. The only thing we care about is the data model, which is a file, a text file encoded into YAML format, which, if you believe me or not, and you can see it from here, it could also really look like a running configuration on the devices. It's not that different, right? And this file is going to contain the configurations for our entire networking infrastructure. The Vxlan as code will be able to read this file and implement whatever it is required in order to push this as an intent into NDFC. Now, the pros definitely are the fact that we do not need to know anything about coding. We do not need to know anything about playbooks. We can automate everything. The cons about this is that the functionality, I would say, is very new because it was released in the past summer, so 3-4 months ago. It's still missing some of the capabilities that NDFC can expose, but there is an active development going on. So I know that they're going to release the next version quite soon, and that is going already to include some new cool functionalities. But we're going to talk a little bit more about this later on. Let's understand what is the Nexus Dashboard API architecture first, because that is going to be the key for understanding all the upcoming discussions. APIs are the automation primary interface when it comes to Nexus Dashboard and Nexus Dashboard Fabric Controller. They are enabled by default because the web UIs of ND and NDFC, as well as NDI and NDO, are using those APIs. They are HTTP APIs, and we can use the REST, the common HTTP REST framework in order to interact with NDFC. That means that we have the normal methods, the normal HTTP methods available, get, post, put, and delete, which will allow us to read the data from NDFC, to add new objects to NDFC, to modify these objects, or to delete them when we need. One important point to understand, when we talk about Nexus Dashboard, you know that as of today, Nexus Dashboard is the common underlay platform. And when we talk about APIs, Nexus Dashboard is still the first point of contact, the first point of gateway, let's say the first gateway that you will have to hit in order to talk in a programmable way with all the services exposed by Nexus Dashboard, like Fabric Controller, Insights, or Orchestrator. It means that on top of Nexus Dashboard, we have a container, which is called the API Gateway container. And this container is able to understand, based on the URL, what API call we are making. And based on that, it will redirect the API call to the correct container. For example, the Fabric Builder container of NDFC or a container of NDI, and so on. Authentication always is done on Nexus Dashboard itself, and it is compliant with the role-based access control that we have defined there. You know that Nexus Dashboard Fabric Controller supports RBAC. It allows you to define different authorization profiles depending on users, depending on groups, and based on the authorization profile, some users or some groups might or might not be able to access a specific fabric. This is true for the web UI. It is also true for all the API calls. Where can you find documentation about APIs? Because this is the most important thing if you plan to have some sort of direct interaction with the APIs. Now, there are two places. An online page, which I'm going to paste into the chat as we speak. The online page provides you a developer guide, which is going to contain basically a getting started guide, some general information on how you have to handle authentication, how you have to make the API calls, what are the structures, and so on. And it also contains an API reference, which is very important, and we're going to understand why in the next slide. There is also another option to get additional documentation, to get additional API testing tools, and this is inside of Nexus Dashboard. If you point your browser to your Nexus Dashboard IP or hostname /#/help center, that will open the page you see here on the slide, which is the Help Center. From this page, there is a programming section with two links. REST API is an embedded API reference, which also allows you to have some sort of interaction. It also allows you to play a little bit with APIs, and I will show you how in a little bit. And then you have a link of the to the developer guide, which will take you to the online page I just pasted into the chat. Now, we were talking about API references, right? Why is that? Because API references are the key part of interacting with APIs. API references are indexes that contain the information about all the different API calls that we can make into a system. They do not only contain the list of the different URLs, they also contain information on what are the parameters that we have to specify when we want to send data to the application. In our case, if we take as an example this API here, create network, which will allow us to define a new network into Nexus Dashboard Fabric Controller, you see that this page is telling us, okay, you will have to use a parameter inside of the URL, and this parameter is the fabric name. So we can see exactly where we have to use the fabric name inside of the URL. In addition to this, because we are posting data, because we want to create a new object, we also have to pass some sort of payload using the body of the HTML request. And down here, we can see an example of the payload we have to send that contains all the required information to create a new network. If you are not sure about which items, which parameters are mandatory, which ones are not, or how a parameter should look like, we can click on the button close to example value, which is called the schema. And the schema contains all that information. Remember one thing, into the API reference index, we list all the APIs that are validated, that are supported, and the ones that are being tracked. Meaning that if at some point we decide to deprecate an API call because we created a different one that offers multiple or better functionalities, we are going to notify you that into the release notes of the newer Nexus Dashboard version. You might be tempted, if you are skilled with APIs, to inspect what are the APIs calls that are made by the web UI, in case you do not find a valid API call inside of the reference. There is no problem with that technically, meaning that it will work even if the API is made from an external tool like a script. But remember that we might decide to change all those APIs that are not part of the API reference at any time without any notice. So that means that it could break your scripts. Just remember this point, which is very important. How do we authenticate into Nexus Dashboard? Two options. The first option, we pass to Nexus Dashboard /login page a payload that contains the username, the password, and the authentication domain. Now, the fact that we can pass also the authentication domain is also telling you that we support, for this kind of authentication, both local users as well as remote authenticated users, in case you're using TACAX, Radius, and you have attached them to Nexus Dashboard. The token that you get if the input you have specified is valid, is going to be valid by default for 20 minutes. After those 20 minutes are expired, you can obviously refresh the token within that time, or you can re-authenticate again. For all the subsequent API calls that you want to make, remember that that token that was received by NDFC, that was sent by NDFC, has to be attached as a cookie for all the API, for all the API calls that you're going to make subsequently. Now, this might not be the best option in case you want to use some sort of automated scripts, because you do not want every time to input the password, nor you want to store the password somewhere close to the script, like the files to the script. Due to this, we have another options. And the option is the API keys. Now, every local user, not remote users, but only local user, can request an API key to be generated, up to 10 API keys for every user. This API key can be used inside of the headers every time you are going to send an API request to Nexus Dashboard Fabric Controller. That is going to be enough to tell Nexus Dashboard Fabric Controller, hey, I'm receiving a request from user Alessandro. I know that user Alessandro has these authorization rules, so I know exactly what he can request and what he can access. And this is a much better option, especially in the case where you want to embed this in some sort of scripts. When we talk about supports of Nexus Dashboard API, what is important to know? First of all, they are integral part of Nexus Dashboard and Nexus Dashboard Fabric Controller. That means that if something is broken, if the APIs are not responding as they should, if the APIs are not responding with the payloads that we are expecting, we might open a tag case and ask tag guys to verify and eventually create a bug that is going to be sent to the BU for fixing the problem. But there is also another route that you can have, and this is the Cisco DevNet Data Center community. Here you can post more general questions. For example, hey, I'm trying to use this API call. I don't really understand how I should do, or I cannot authenticate using an API. Can somebody help me? That is also valid. Remember one thing though, it's community-based. That means that it's best effort, there are no SLAs, and there is also no privacy. So you really need to be careful on what data you are posting. Do not post passwords, do not post sensitive data. That is very important. Now, 3 different ways to interact with the APIs, and then I will show you in a demo one of them. The first one, the API test page available in Nexus Dashboard. This is what I was telling you before. You open your browser, you point your Nexus Dashboard hostname or API, or IP, /API docs. That will take you to this page here, right? Which contains the list of all the supported APIs, and it will also contain a way to play with the APIs. For example, I have selected the one that says list the role of all or given switches. The information in the page is telling me, hey, you need to pass these specific parameters, the serial number of the switches, but it also allows me on the right side of it to input the serial number of the switches, to click on the run button and to see what is the result that the API is going to return me. This is filled as well with examples that we can take a look in order to understand better how we have to pass the parameters and so on. Obviously, in case you're running multiple services on top of Nexus Dashboard, you will have to select the right one. You see into this section of this slide, in the API documentation, you have as well the option to select or to switch between Nexus Dashboard, in my case, NDFC or NDI or NDO, in order to have the correct reference. If you do not want to do this over the Nexus Dashboard Web UI, there is also the possibility to play along with the API testing tools. One of the most common one of the most known one is Postman. Now, Postman allows you to define all the different API calls that are exposed into NDFC and to see what the integration would look like, to understand what is the payload that the API is going to return you, what is the payload that you have to send to the APIs. Now, it might be a problem doing all this manually, right? Defining all the different APIs that you see here manually, because there are hundreds of them. And in order to help you with this, I'm pasting just now into the chat, we have released a Postman collection that contains all this information, that contains all the APIs that are exposed into NDFC. That will allow to import the collection in Postman and start playing with that. Last but not least, we talk about programming languages. Now, programming languages are very flexible. They allow us to do everything. There are no limits when we have programming languages. Most of the times we use high-level programming languages. That's why I use the Python icon here. At least that's the one I use the most, right? I love Python. Why do I love it? Because like I was saying, it allows me to do any kind of action. It allows me to integrate with any kind of tool. It allows me to do any sort of logics, any sort of data manipulation that I need in order to implement my own logics into an automated way. And now I want to show you a demo about this so you can understand what I'm talking about. Let me switch to Visual Studio Code. And by the way, I will post into the chat as well a link to the GitHub repository that contains all the examples that we are going to use today. This Python script here, as well as the Ansible playbooks and the and the Vxlan as a code data model. So you have everything here in case you want to explore it, in case you want to play a little bit with it. Now, we were talking about a Python script. Let me start first describing what is the goal of this Python script. You know that Nexus Dashboard Fabric Controller keeps track of the running configuration on the devices. If the running configuration is not the expected one, meaning that it's drifting from the intent that Nexus Dashboard Fabric Controller is storing, that device is going to be reported out of sync. And it is important for you to understand why the device is out of sync and to remediate that. Now, in the case where you do not use Nexus Dashboard Fabric Controller constantly, maybe you use it once a week, once a month, who knows, it is sometimes hard to understand if the devices are out of sync because you don't have direct impact on this. There is no automated messaging that is sent out from Nexus Dashboard Fabric Controller. So one of the things I was having in my mind was, hey, why can't we automate this? Why can't we have a script that connects to Nexus Dashboard Fabric Controller, that get the list of fabrics, that get the list of devices, look at every single device, and if the device is reported out of sync, it has somehow to notify the network administrator. And this is what I'm doing with this script. Obviously, I don't want to spend time explaining all the different options. Let's just see it in action. You can, by the way, take a look at the script because I just pasted the link. But now, let's move to NDFC, right? We have a couple of fabrics, the Vxlan fabric and the core fabric, the external fabric. We open the core one, and you see the device is in sync. This is what NDFC knows about the configuration. We open the Vxlan fabric, and we also have all the 7 devices in sync. Let's try to change this. So we are going to open the device, and as you can see in this case, I'm using CML. I will open the core device, and I'm going to change some configurations manually, right? Because we still can do that if we are using NDFC. Nobody stops you to go on the device and change the configuration manually, even though you should not do that. But with this script, we can understand if someone did it. So let's do show run interface Ethernet 1.1. I think this is a configure. Yeah, this is a interface configured by NDFC. Is providing connectivity between the external fabric and the Vxlan fabric. Now, what I will do a quick change. So interface Ethernet 1.1, better. Then we're going to change the MTU, right? From 9012.16, we're going to set 9000. If we go back immediately into Nexus Dashboard Fabric Controller and we open the core fabric, you see that the device is still in sync. But this is normal because NDFC performs the configuration compliance verification by default once per day. It means that it could take up to 24 hours to NDFC to understand that there was a change. This is something that you can change, though. It's something that you can change manually and reduce it down to maximum or minimum 30 minutes. Now, let's see what the script would say in our case. So I'm going to expand a little bit my terminal. I need to get into the API interaction folder. And now we're going to do Python 3. And the script name is check and report status. We run the script. And like I said, the script is going to connect to all the devices, to NDFC. Is going to get the list of devices. Is going to check for every device what is the status. Now we have 2 ways to check the status, and that is going to be dictated by this mode that we are setting here, aggressive or not. Now that we are using the aggressive way, we are simply telling NDFC, hey, I do not care about what status you know now, really as of now, like we said before when we opened the core fabric. I want you to pull the latest running configuration from the devices and compare that one with your intent. And you see that the script is telling me device core 1 is not in sync. And it is also notifying the administrator by sending a WebEx message. So if I'll open the WebEx window as of now, and we scroll up a little bit, you see 10:38, which was a few seconds ago, we got this message. Device core 1 in Fabric Milan CML workshop core is not in sync. And is also telling us what is the difference in terms of configuration that should be applied to the devices. This is what NDFC is providing. At the same time, if we go back to NDFC again, and we refresh this page, you see that the device is reported out of sync because the script triggered the configuration compliance review on NDFC. And this is just one possible use case. But the real point here is that with scripts, with code, you can do pretty much whatever you want. Now, I'm going to open a new poll around this section. Actually, I have to open two polls, sorry, because there was also one about the previous section, which I did not open. So I will leave this one open for 5 minutes, and then I will open the API architecture one. And in the meantime, I will switch back to my slides. Now, demo done. The question is this too much for you? Is it too complex to play with Python, to play with code? But that is not a problem at all. The reason is, again, the same that I said before this morning, right? We are in 2024. We have so many different tools that allows us to interact in an automated way with several applications, with several architectures, with the complexity that we need, meaning maximum complexity, coding, minimum complexity, the maximum level of abstraction that we can have. Today, we are going to learn two of them. We will start with the Ansible. And I will start by talking a little bit about the integration we have between NDFC and Ansible. The first important thing, let's try to review the Ansible architecture. I'm not intending to explain to you how Ansible works. That is going to take me probably hours, which I don't have. I will try to do this just in a couple of minutes. Now, we know that Ansible is an automation tool. That means that it's a tool written by someone else that allows us to benefit from some core functionalities, from some core binaries, to implement some sort of logics that we can define, but that are going to use the inner binaries of Ansible in order to be pushed, in order to be rendered and applied to the applications, to the devices that we want. Now, Ansible is totally written in Python. And now you might be saying, well, you just said that I do not need to know anything about coding. And that is still true, because the places where we find Python in Ansible are the core functionalities, the binaries of Ansible, and the modules. Now, the modules are add-ons that we can add to the vanilla installation of Ansible, and that will allow us to interact with different applications, with different architectures. Into today's use case, we can talk about the modules that are going to allow us via Ansible to talk with NDFC. This is what we are going to see. But the beauty of all this is that you do not need to care about the modules, nor you need to care about the Ansible core binaries or code. That is something that is going to be totally abstracted to you. No need to know Python. What do you need to do then when you start using Ansible? Well, in the context of NDFC, we have three different sections that we might be aware of, that we need to be aware of. The first one is the Ansible configuration file. Why is that? Because Ansible requires a couple of changes, a couple of parameter change around timeouts when it has to speak with NDFC. Something that you do once, the first time you install the modules for NDFC, and then you can forget about it. The next file I want to talk about is the inventory file. Even this one is something that you mostly touch once, the first time you start configuring Ansible, and then you can forget about it. The inventory file contains the information about NDFC. What is NDFC hostname, or what is NDFC IP, what's the username, the password that I have to use in order to interact with NDFC, and additional parameters that we might set or we might not set depending on our use case. Everything is documented, by the way. There are no surprises here. The last bit and the most important one are the playbooks. The playbooks are the text files, even in this case, they are written in YAML, that tell Ansible what are the different operations that it has to do. So the playbooks contain information on what is the automation we want to run, in our case, towards NDFC. Playbooks contain list of tasks, and each task has to be binded to a module. The modules, in our case, could be all coming from the collection that includes the NDFC functionalities, the NDFC modules, or can be also other modules that allows us to integrate, to interact with other applications, something that we're also going to see into the Ansible demo. Now, where can you find the documentation on how to get started with Ansible? Well, we have the Ansible Galaxy portal that contains the information about all the collections. When I say collection, the collection is the name for a group of modules exposed, shipped by the same entity. Like in this case, we have the collection cisco.dcnm that contains all the modules that we can use to interact with NDFC. So if I'm talking about NDFC, why is it called DCNM? That's the question you might be asking. Well, if you remember, NDFC is coming from DCNM. NDFC is the evolution of DCNM. And the Ansible collection can work with both of them. It was existing also before NDFC. That's the reason why we kept the original name. Changing it at this point might be quite complicated. We will see in the future what we can do. So now you can access the Ansible Galaxy portal. You can move to the cisco.dcnm collection. And here you have the first page that is going to tell you how to install this collection and how to start using it. What are the initial configurations? I want to tell you that this collection is developed, is maintained by Cisco. Especially in the last months, there has been a lot of changes. We have introduced a lot of new modules that you can use. So the next exercise I want to do, let's try to understand what are the most important modules around NDFC. I have divided them into two categories, not because they are working differently, but simply because most of the times I've run this kind of NDFC webinar series, we were talking about Vxlan EVPN fabrics. So I think it is important to differentiate what you can do as well into those fabrics. Now, talking about Vxlan EVPN. With Ansible, we can totally manage the Vxlan EVPN fabrics. We can manage the VRFs that we want to attach to these fabrics and that we want to extend to these fabrics. We can manage the networks, we can attach the networks, we can define, modify, delete the networks. We have the full lifecycle control about the overlays, basically. We can also define policies around the service nodes, the layer 4 to layer 7 service insertion devices. We can create the policies, the nodes, the interfaces, the connections, and so on. Everything through an Ansible module. And then we have also the other modules, the more general ones that are applicable to any kind of fabric configured into NDFC. We have the DCNM fabric module that allows us to create those fabrics, to define their properties. The inventory module, another important one, which allows us to import the devices into the fabrics. We have the VPC pair that you can imagine what it allows us to do, right? We have the policy module. We also have the DCNM module. Sorry, the DCNM REST module, the last that you see here, which is very important, and you will understand why in a little bit. All the ones which are flagged with an asterisk are the ones that we recently released. So the fabric, the VPC pair, and this DCNM image XX, which contains multiple modules, right? There are multiple modules that are all prefixed with DCNM image that allows us to handle the life cycle of the image management of the devices controlled via NDFC. Let me show you just a few examples over the slides, and then we're going to jump into the demo. And by the way, I will switch the survey now.
Alessandro,
You did?
I combine them both. Yeah. So they're both running.
You are a legend. Thank you.
No problem.
All right, so like I was saying, DCNM Fabric, right? This is maybe the first module you want to start with NDFC. What it allows you to do? Well, it allows you to create fabrics. Fabrics are different, right? Depending on the template we want to use. We can have the Vxlan VPN fabrics, we can have the external fabrics, we can have the ISN, the inter-site network fabrics that are going to put multiple Vxlan VPN in communication over the multi-site domain. You see from the example here that the configuration is pretty easy. We create or we provide the name to our task. We associate to the task the module cisco.dcnm.dcnm fabric. Again, this is the structure we have been seeing in the previous two slides. We tell about the state, which controls what is the operation we want to do into this task. And I will get back to the state in a few slides because this is very important. And then we pass additional configuration parameters to the task so that it knows exactly what is the payload that it has to send to NDFC APIs in order to create the fabric. Why is it not moving? Let me click. All right. The next one is the DCNM inventory. Why do we use the DCNM inventory? Well, we use it when we have defined the fabric and we want to start adding devices into the fabric. Exactly the same you would do by the web UI. How do we add the devices? Well, we can discover the ones that have already been configured with their management IP, easy peasy, or we can also use the module with the POP option, as you can see now into this example, and this will allow NDFC to listen for incoming DHCP requests from the devices looping into the POP phase. If you remember, the POP for Nexus is the zero-touch provisioning process, and once NDFC listens or gets a request from the device, it will send its initial configuration as well as the software image that we have specified into our policy. Like in this case, I'm saying 10.4.2, right? Actually, I don't think this is the right parameter. Probably there is another one that you have to use, but still, you can tell through this playbook what is the image that NDFC has to send together with the initial configuration. We can have the DCNM network policy. Well, let's not spend too much time over this one because we are going to see it into the demo, but you can understand what it allows us to do. We create overlay networks, and we also attach the network to the devices where we want to trunk them. This is interesting, DCNM policy. Now, you know that NDFC is fully based on policies. Policies are created when we run the NDFC workflows. For example, when we create a network and we want to attach the network to a device, in that case, NDFC creates all the required policies and attach those policies to the devices. Policies are also important for the fabrics which are not Vxlan VPN fabrics or which are not easy fabrics, the one that have all the inner automation workflows. Why is that? Because policies are basically templates that allows us to specify parameters, and once we have associated a template and we have passed the required parameters and we have made the association all together with the device, at this point, NDFC knows that it has to render that specific template configuration and push it into the device. Now, think about the use case you're partially seeing here, and I will also send to you a playbook. You can also find the playbook in the file, to the GitHub repository that I sent you before. It's called Playbook 4 that contains the full example. But the idea here is to configure a fabric which is not an easy fabric, for example, a core fabric or an ISN fabric. Now, NDFC by default doesn't know much what it has to do with these devices. It doesn't know if it has to create OSPF configurations. It doesn't know if it has to create BGP configurations, unless that is for the direct link interconnected with the Vxlan VPN. But with the policies, we can push all whatever we want in a programmatical way. In this case, for example, for this device here, IXN1, I'm easily telling NDFC by Ansible, by this Ansible playbook, hey, I want OSPF attached to this device. I want an OSPF process to be added to this device, and I want these parameters to be passed to the OSPF process. Now, what am I doing here? I'm combining a variable statically defined into the playbook together with another set of variables defined outside, which are common to all the OSPF router configurations that I want to attach into the fabric. The translation of this playbook will look like this into NDFC. It's going to look like a policy which is attached to a device, a policy template using the router OSPF classic template with all the parameters that I have specified before. And the final iteration of all this is the following one, the generated configuration. Now, this is what NDFC does in terms of automation natively. It generates the configuration of the policies and it pushes them to the devices. What we have seen now is how we can trigger all this in a more programmable way. And the last module I want to cover over the slides is the following one, the DCNM REST. Like I was telling you before, this is very important because it allows us to trigger any kind of API call we want towards NDFC in the case where there are some functionalities missing into the NDFC Ansible module or Ansible collection. Example you see here. What are we doing? We have defined two more tasks. One task called recalculate and one task called deploy. Why is that? Because there is no native module for the Ansible collection that can do this into the fabrics. Now, what are we doing then? Well, we're simply sending a post, an HTTP post, using this API URL here. And this, obviously, you need to know the API URLs at this point, but this is going to trigger the recalculate first with the config save route and the config deploy, the deploy operation later on. Now, why is it very important? Now, let me tell you this story very briefly. You remember when I show you all the modules into that slide, at least the most important ones, the ones that were marked as new is something that we have released into the past summer. One of them was very important, the fabric, the DCNM fabric module. Before we had that option available, every time I wanted to create a new fabric, I had to use the DCNM REST module. I had to use the API URL that was the correct one in order to create a new fabric, and I had to pass a huge payload of data inside of that API call, all the data that was specifying the configuration of that fabric. Now, instead that we have released the new module, I'm simply using that one, and that simplifies my life. But still, I always have a fail-safe in case the module cannot do something that I would like to do in NDFC. Where can you find documentation about the modules? Where can you see if the modules parameters are mandatory, are required, or not? What are the different choices? The answer is the same as before. The Ansible Galaxy portal. Again, you look for the Cisco DCNM, and then you have the documentation option I'm highlighting now, and this will tell you to the page that is going to list all the different modules, and on the central column, you'll get all the details about that. Did you lose me? Because my I see the VPN client flopped.
No, all good, Alessandro. But
okay.
I'll take opportunity to raise a question to you, okay?
Yeah.
That we got in the Q&A.
Yeah, go for it.
The question is, if I'm using a policy to configure an interface, do I use DCNM policy module to edit the configuration, or do I use DCNM interface module for that case?
You do the interface. I mean, if you have a more specific one, because remember the policy, all right, is going to generate the actual policy template into the policy list of the fabric. The interface does the same at the end, because at the end it's just a matter of policies. But I think it's more, how can I say, it's more logical to use that one because it would be the same action as going into the interfaces list and changing the settings of the interface there at that point. Because remember one thing, that the interface policy, the interface policy, the interface template, might be also generating multiple policies. Not a single one, but multiple ones. So if you use the DCNM interface module, it means that it will cascade, it will generate all the required sub-policies. If you do it by the policy instead, you might have to create multiple ones on your own.
One by one. Yep.
Yes.
Understood. Thank you, Alessandro.
No problems. no problems. Now, the very important thing I was telling you before, the states of the module. Every time we define a task and we attach a module, most of the times, let's say, we also have to provide the state. And the state defines the condition of the object into NDFC. If we are using merge, and by the way, if you don't get this from my explanation, because it's not that immediate, to be honest, if you don't get this from this slide, I will show you in the demo what I mean. But if I use merged, it means that I'm going to push any new objects or any missing objects into NDFC, and I'm going to update them in case the information I have into the playbook is different from the data I have into NDFC. If the playbook is missing some parameters, I don't care. I will not touch the ones I have in NDFC. Replaced is quite similar, but there is a substantial difference. We still create an object if it's not available, if it's not already defined into NDFC, but in the case where the object is defined in NDFC, we take a look at all the properties we have into the playbook. If any property, if any data is different on NDFC, we are going to replace it with the one we have into the playbook. But for all the properties that are not defined into the playbook, we are going to reset the ones in NDFC. So we are going to set the default values. And this is something very important. The next one is the most dangerous. I mean, if I could have an entire slide with a red flag, I would probably do that. Why is that? Because with overridden, we risk to delete everything we have in NDFC, which is not specified into the playbook. Example, in my playbook, I have only 2 networks, and I'm using the overridden state. That means that those 2 networks are going to be created or updated, but all the other ones that I have in NDFC are going to be removed. Something very dangerous. My take on this is that you should use overridden. Well, you should not use overridden. You should use it only if you're extremely sure about what you're doing, because it's very dangerous. Deleted basically means, okay, the network I have listed into my playbook, into my tasks, are going to be deleted. Query, I will use query when I simply want to retrieve the current status, the current configuration of that specific object, for example, the network, the VRF, or the switch, that is contained at the moment into NDFC. But like I said, I will show you this in a demo. Before we jump to the demo, though, let me talk a little bit about support even for Ansible, because it is important to understand. Now, the collection, the Ansible collection for DCNM/NDFC, you can still manage both of them with the same collection, are maintained by Cisco, like I was telling you before, and are publicly available. It's open source, right? We host all the code on GitHub. How can you get support for this? Well, the way is the community way. So you either open an issue on GitHub if you're running into some weird problems, or also if you need some sort of information, or you can use the Cisco DevNet community. Again, another portal, another place where you can get all sorts of help from from automation experts coming from all over the world. Remember, though, that this is still community-based. So that means no SLA, that means no privacy. Remember to be extremely careful when posting data, when posting traces, when posting logs that might be containing sensitive information. There is also a learning path available for NDFC. If you want to take a look, I'm listing the link into this slide. And this contains Ansible examples as well as Terraform examples. So at least you can see, you can understand the difference between the two of them, like I was telling you before. All right, let me move to the demo and show you some action with Ansible. I'm going to switch again to my Visual Studio Code. First thing I want to do, I want to open the right folder, the same that you are going to find into my repository that I posted before. So we are going to use Ansible examples, and we're going to expand the playbooks folder. Let me close this file here, and let's start with playbook number 1. Now, let's also change folder into the terminal. Ansible examples. All right. Playbook number 1 is showing you a very easy example on how we can create VRFs, and how we can create networks in Ansible. Obviously, we have two tasks. The first task is going to create a VRF. The second task is going to create one network for now. It is, both of them are attached to a module, to a DCNM module, DCNM VRF and DCNM network, and both of them contains additional information, like where is the fabric that where I want to apply this configuration, what are the additional parameters, for example, or the additional payloads that I want to send with this module. In my case, I'm creating a single VRF called Ansible static VRF with some templates, association, and so on. If you are not sure what are the mandatory values, you can refer to the Ansible Galaxy portal looking at the Cisco.dcnm documentation. For networks, we do something very similar. We are creating, actually, you see, this is something I left from my previous test. So I will move to merge again to the state to show you all the possible options. But for networks, we're doing something very similar. We are defining a network. We call it Ansible static network 1 with some parameters, net ID, VLAN ID, subnet, and where we want this network to be attached. Take a look at this option here, deploy true. What does it mean? It means that at the same time when we are going to push the configuration into NDFC, we are also going to trigger the recalculate and deploy. Now, if you have one network, if you have two networks, that is fine to leave the deploy at this point. If you're pushing 50 networks, you might do not want to do that. You might want to set the deploy option to false, and only at the end or after the create network tasks, you want to trigger a full recalculate and deploy for all the fabric. What's the difference? If you do the deploy every time you create a new network, and this is going to be a loop on the module, you will have to wait for the recalculate and deploy to happen, which probably means 1 minute wait. If you multiply that for 50 networks, it means that you have to wait 15 minutes idle just for the recalculate and deploy to happen. But let's avoid this now, and let me show you how you can do this. Imagine that we also want to create a second network, by the way. Imagine that we are going to take all this, right? We copy it, we go to a new line, and we paste it. Now, exactly the same, we can keep the same information, we can keep the same data into the playbook. The only thing we're going to do, we're going to change the network name, we are going to change the IP very easily, we are going to change the VNI ID, otherwise NDFC is going to get upset with us, and we're also going to change the VLAN ID, right? Just to have different things. We can reattach the same network to the same devices, to the same port channel, which is a VPC port channel in this case. Now, let's run the playbook. And while the playbook runs, we can also jump into NDFC and check what was the current configuration. So in order to run the playbook, I'm going to do Ansible playbook -i, which is inventory. And I will tell Ansible which is my inventory file that contains information on NDFC. And then I want to run the playbooks, playbook 1. The last thing I will do, but this is just in my example, in my playbook, I will also add ask vault password because some of the secrets are encrypted. So enter, I'll pass this vault password. And while this is running, we jump back to NDFC and we take a look at our fabrics here. We move to the VRFs. See, you see, we do not have a static VRF yet. If I'll try to look for it, find it, static, there is nothing static VRF because it is actually getting created now. Let's move back to Visual Studio Code. Okay, VRF should be created. So while the networks are created, let's go back here and hit on refresh. And there we go. We have the static VRF defined. You see, it is also in progress. Why is it in progress? Because while we are creating the networks, actually, we already created the networks in the meantime, we are also triggering the deploy, which means that VRF is going to be deployed into some devices. So if we go back here now and we hit the refresh again, there we go. The VRF is deployed, all good. If we move to the networks and we take a look, we have static network 1 and static network 2 deployed. Double click, network attachments, and we see that they are deployed into port channel 10. Perfect, exactly what we wanted. So before we move to the next playbooks, let me just show you over this example, what are the differences between the states. Instead of merge, we are going to use replaced. Now we keep the configuration as they are. The only thing I will do is I will remove some options. Do I have something I can change here? Not really. Not really. I should have added maybe a description before, which is not here, but let's maybe just do net, I think is description. Let me take a look from a different playbook if we have it. Net ID, net extension, it's not. All right, let's take a look. Ansible Galaxy, Ansible DCNM, and we take a look at what options we have in order to set a description. So documentation, we open the network one and we find description, interface description, for example. There we go. All right, so playbook one, interface description, and we give the same name as the network name. And we do the same down here, right? Because we are using replaced, it means that if the value is not into NDFC, we are going to push it once more. So let's do this and let's filter just the network tag, sorry, the network task, tags, networks. If, for example, we did not have, or we did had the description before, and we were going to remove it at this point, that would have been deleted from NDFC. So that's the reason why you need to be careful about replaced. It's still, let's say, dangerous, but not as dangerous as what we're going to see next. So if we move to NDFC again, and we open the static network settings, edit, see, now we have the interface description updated. Let me change that, all right? All right, let's be as much dangerous as possible. Let's do overwritten, and let's trigger the playbook again. Now, this is going to take a little bit because obviously, like I said before, what the playbook is going to do is going to remove all the networks which are not defined into this list. So it means that here, if we move back to our network list, in a little bit, we should start seeing some changes because the playbook will start removing the networks. And in order to remove the networks, it has also to undeploy them. It has also to detach them from the devices. But you see that this is already happening. So we give it some time in the meantime while this is running, and I'll show you how this could be built in a more let's say in a more sophisticated way. The same playbook. Now here, playbook number one was all hard-coded, all the names, all the variables, or the IPs. If I show you playbook number two, we are not going to run it, by the way, I'm simply going to show you, you see that there is nothing hard-coded. Here, we are importing into the playbook a variable file. No, there we go, a variable file, which, if I'll open, contains simply a list of VRFs and networks. Here we define only the information, only the data. Then the data is imported inside of the playbook, and the playbook is going to loop across the different lists of VRF or networks. Why is this nice? Because it allows us to create our logic into the playbook, and it also allows us to add additional objects without touching the playbook itself. The playbook is going to read the data from an external variable file. So there is no risk that we are going to change the structure of the playbook, change the logic of the playbook by mistake. Another important thing, right, that you can implement. Now, the previous playbook's finished. So if I'll open again my NDFC and I'll click on refresh, ta-da, you see, everything is gone. We are only left with static network 1 and static network 2. Very, very dangerous to use the overridden option. Last thing I want to show you, and then like I said, playbook 4 is more for your reference in case you want to manage some fabrics which are not part of a Vxlan EVPN architecture. But playbook number 3 does even more. Playbook number 3 is going to connect to my IPAM and is going to read from the IPAM the list of different VRFs, prefixes, meaning networks, and VLANs I have there. So if I'll go back to my browser and I'll show you my IPAM netbox, you see that I have a tenant here, which is using the same name as my NDFC fabric. Inside of this tenant, I have 4 VRFs, I have 5 prefixes, I have 6 VLANs. Now that NDFC, sorry, that Ansible playbook is going to connect to Netbox, is going to read that information, and is going to push it to NDFC. So while this is happening, I will explain you a little bit more things. Let's remove the tags, and let's change the playbook number 3. All right, so you see we still have different tasks. Create VRFs, create networks, second task, where there is also a task where we are reading the network from the IPAM. And also we have one more, create VLAN port group. Now you see we are changing the collection here. We do not use the Cisco collection anymore, we use the VMware. Why? Because we also want to create those networks into the distributed virtual switch. If I'll show you that, hopefully I'm still logged into the vCenter. If I'll open, where is my DVS Vxlan topology? If we go to the networks, you see we have a few of them, 6 networks. Now, by the time the playbook is going to finish, and now it's still creating the VRFs, but by the time the playbook, it will finish creating VRFs and networks into NDFC, it will also get the same data from Netbox and configure the port groups on the vCenter. So just give it a few more seconds. Do we have maybe some questions we want to take out loud in the meantime?
Yes, we have one that came up a couple of minutes ago. What modules can we use for automation when we are using federation? I believe it means federation
One
of
manage.
NDFCs, one manage, yeah.
One manage, yeah. There is no module yet available for that because the federation came out in July, end of July. So Ansible collection is not supporting the one manage yet. We do have all the APIs available, but obviously I don't know if that is going to be enough, or if it's going to be good for you. So if I'll do one manage, you see we have this section here, multi-cluster fabric, the deployment, and so on, in order to handle all the underlay, the overlays across a federation. But it's not yet in the Ansible collection.
Yeah, this customer is using Ansible already, so yeah, he will need to wait until we deploy this. Then
I will ask our colleagues from the BU who are working on this and understand when they plan to implement it.
Yeah. Thank you, Alessandro.
No worries. All right. So
by the way, I triggered the poll about Ansible. Okay, so you should find on the slide of the poll.
Perfect. Yes. Please let us know what you think about this. As Alejandro was saying, that the poll is open. So let's go back to our networks, and you see that we have more networks created here. These are all the ones that are contained into my netbox. There we go. We have, where's the name? Oh, description, Nexus Dashboard, Nagios, Web Server, DB Server, LDAP. All of them are getting created here. And probably at this time, let's scroll down. There we go. We should have done also the vCenter side. So if I'll move back here, there we go. We have all the port groups defined on the vCenter. So you see, even with Ansible, we have full automation capabilities. Now, let's quickly move to the latest section, which is Vxlan as code. Vxlan as code is something very new. The module Vxlan as code, which is part of network as code, which has been existing for quite a long. Now, the main goal of network as code is to give you the possibilities of managing several types of architectures for applications developed by Cisco with an infrastructure as code approach. With infrastructure as code, like I was telling you before, we can define the entire configuration for those applications using easy to read, easy to write files. In the Vxlan as code, the file is going to be a text file written with YAML encoding. Why infrastructure as code is good? Because first of all, it allows us to keep track of the different changes of our infrastructure by simply tracking the file in a version control system like Git, like SVN. It allows us to better collaborate across different teams. It allows us to implement the Git change control, for example. Every time we want a new change, that could start into a parallel branch, and that the branch has to be merged following the proper pull request operation or workflows. Now, the beauty about this is the fact that, on top of what I've just said, obviously, the fact that you have to worry only about keeping track and configuring the data model, which is the file that contains the information. Whatever is behind the data model, whatever the automation is doing, is totally transparent for you. You do not have to care about that. You simply edit the configurations and then you start the automation using whatever command it is required for that specific module. In the case of Vxlan as code, the command is going to be an Ansible playbook, but you do not need to care about the playbook at all. This is an extract of the data model. We are going to see this in my demo as well, where I can show you everything what I have configured. The high-level order of operations is the following one. You start with the initial configuration, which means you are going to download from the GitHub, because this is an open source project. You are going to download from GitHub the repository that contains all the data. You follow the instructions, you install the additional modules locally on your machine, and that's it. Once you've done the initial configuration, your only focus will be on the data model definition. The data model then is going to be pulled, is going to be read by the automation process itself. And the automation process will do multiple tasks. It will validate your data model, and I will give you all the details in a second. It will create all the objects that are inside of the data model into NDFC, and it will deploy them into the fabric. At the end, it will also keep track of whatever is not defined anymore into the data model and remove it from NDFC. Now, let's try to understand these different roles, these different tasks. We start from the validate role. You might be using several files to deploy the data model. This is what I do. Why? Because I find it more logical. I'll find this using a better organization. I have the file where I only contain the configurations about the fabrics. I have the file where I only contain the configuration about the devices inside of the fabrics, like the switches that I added to the fabrics and the interface configuration. And I have the files that contain my overlay networks. Maybe I'll divide each application into a different file. The validate role will first of all combine all of them in what we call the full data model. Once we have this, the validate role will also take a look at the syntax which is expressed inside of the data model, and it will flag any potential problems. Now, there are additional validation steps that are offered part of the Cisco CX, the Advanced Services business unit of Cisco. This framework is coming from them. They can add additional validation roles. They can integrate all this into more sophisticated pipelines for you. This is a service that they offer. We can probably paste the link into the chat later on, or we can send you this information that contains all the different options that can be included by the CX Advanced Services. What I will show you today, by the way, is just the basic stuff that you can get, let's say, over the community release, whatever we are exposing publicly outside. Once the validation is done, like I was saying before, we are going to create all those objects. So the playbook that you're going to run will read the data model, will take a look at NDFC, and will push all the configurations that are required inside of NDFC. It is important to understand that at this stage, configurations are not going to be pushed yet to the fabric. That only happens at the next iteration, at the next role, the deploy one. And by the way, you can selectively decide if you only want to run the validate, if you only want to run the create, or you only want to run the deploy. That is going to be up to you. In the deploy moment, we trigger the final recalculate and deploy. And this will tell NDFC, hey, whatever I pushed before with the create role has to be configured this time on the devices. Last but very important, we have this role here, the remove one. With the remove role, we are going to remove all the objects that are no longer defined into the data model. But again, because this could be something dangerous, they decided to implement it with a second configuration that requires an end logic, meaning that you need to both delete the objects from the full data model and tell the automation that you really want to delete all the networks or all the VRFs or all the devices which are not contained into the data model anymore. If you really want to do that, you have to set any of these options as true. Move. one object from the data model, one network from the data model, I also set this line here, which is contained into the group vars NDFC, NDFC.yaml file. I will also set this option to true. Perfect. That will tell the automation the network that you see in NDFC, which is not into the playbook anymore, has to be deleted, right? It will not be done automatically unless you also change this one here. Now, I will show you how to define the data model, and we are also going to pass you the information about where the data model is explained, all the parameters, all the mandatory values, and so on. Before we move to that section, let me just tell you a little bit about the support. It's very similar as what we have seen with Ansible, meaning that still we are exposing the code over GitHub. But here, on top of this, you have all the advanced services provided by Cisco CX. Like I was telling you before, they can add additional capabilities. They can control this over a full CI/CD pipeline, enhancing the entire lifecycle support for the NDFC, Vxlan, VPN fabrics. So in case you're interested into this, we have the link here that takes to the page where they are exposing all the different services that can be attached to this infrastructure as code model offered by Network as Code, by Cisco Network as Code. All right, we have 6 minutes left, so I will quickly jump to my Visual Studio Code once more. We are not going to trigger any changes at this stage because that is going to take several minutes, because the entire data model, my data model, is exposing the configuration for the entire Vxlan VPN fabric. So normally when I run the automation, it takes 4 minutes. But indeed, I want to show you how I have defined my configurations. So let's start from Fabric. Let me open all of them, by the way, so we can close this section. Can also reduce the terminal. Let's start from Fabric. You see, this is a plain text file, and I guess that if you read it, you can understand what is going to happen. We are going to create a new fabric, right? Its name is going to be Milan CML WKS fabric. It's going to be a Vxlan VPN fabric, and it's going to have all these additional parameters set, like the Anycas MAC address, the Anycas gateway MAC address, the DNS server, the NTP server. I want this specific configuration for the VPC, and all these parameters, like I was telling you before, are, this is the Ansible. So where did I, Network as Code, there we go. All the different parameters, which I'm also sending the link into the chat, are listed into the net as a code. You see, you scroll down, you see all the relations between the different objects, the different attributes that you can set into every section, what are the informations, what are the settings about it, is it mandatory, what are the default values, and so on. Everything is properly documented. And if you go at the bottom of it, you will also find some examples that you can simply copy and paste. But like I said, I'm sending you the entire Vxlan VPN configuration in my repository. And that's it about the fabric. I can define my topology, which contains information about the devices. You see, I have spine 1, spine 2, with the management IP address, with the role, and so on. And then I have my leaves. Inside of my leaves, I can also create the interfaces. Like in this case, I want to add an interface port channel, a VPC port channel. You see, I'm setting the name, which is also going to contain the ID of the port channel, the VPC ID, and I'm telling what are the interface members of this port channel. Everything is going to be done over the topology. Underlay, in my case, contains all the settings about the underlay protocol. What kind of protocol do I want to use? What kind of ranges do I want to use for the usual things that NDFC is doing later on, right? Allocating those point-to-point interfaces, those loopback IPs, and so on. Everything is contained here. And then we have the production overlay file, which contains all the information specifically about a specific application. In this case, maybe it's a production application, whatever, that requires a single VRF. And here I'm setting all the VRF information, and multiple networks. There we go. Network production network 1, production network 2. Interesting enough, you see that all together with the VRFs and the networks, I have this attached group concept. What does it mean? It means that here I can define different groups of devices, or also down here, groups of devices, including their interfaces, And when they are attached to a specific network or to a specific VRF, it will also trigger the final network attachment or VRF attachment on the NDFC side. All this configure in YAML. All this easy to read, which is much faster in case you want to play around it rather than going into the web UI and clicking here and there. So again, you saw the different levels of abstraction that we can have when running automation. We started with running some general code. We then switched to Ansible. And finally, we have saw this final level of abstraction, which is offered by the Vxlan as code. Now, let me go back to my presentation. And we are going to cover the last slide, the summary, right? Because at the end, just to wrap up, I hope I was able to satisfy my initial statement, right? The initial statement that where I told you automation is very important. We have covered the most important benefits. I told you that automation can be applied to NDFC, not only by NDFC itself with the native automation capabilities that is offering, but also by implementing additional workflows, additional use cases that we have seen. We already talked about the different options that you have in order to interact with NDFC in a programmable way. There is no one which is more right than the other. It only depends on you. It only depends on what makes you feel confident with the automation. Do you love scripting like I do? Well, you should also explore the Python possibilities if they give you something that the additional options like Ansible or Vxlan as code cannot provide. But if you are okay with playbooks, for example, stick to Ansible. If you already have experience with Ansible playbooks, stick to that. If you do not want to care about loops, if you don't want to care about variables, you only want to care about a data model that contains only the configuration, then Vxlan as code is going to be your final option. Remember that the possibilities and the integrations you can get with automation around NDFC are infinite. It just requires the purpose. It just requires a goal coming from you, something that is going to help you to the day-by-day operations, into your team day-by-day operations. And then from here, you can build all the automated workflows that you want. I don't know if we have any questions before we close down, Alejandro, or?
Actually, yes, we have a question pending, and then I have a question for you, a little bit tricky one. First question that we have from the audience, from Rohit, is what are the gaps or missing things that we have in Vxlan as code? We mentioned multi-site. Is there any noticeable one, any big one that we can highlight?
All right, one thing maybe important, which I didn't mention, but I think it's very, very, very important. As of today, with the current state of Vxlan as code, I believe it is only applicable for greenfield environments. That means that if you have an existing NDFC which your own fabrics configure, importing the configuration into Vxlan as code might be challenging. I'm not even sure, to be honest, I didn't test it myself. I'm not even sure that that will work fine. So I think that is another big limitation that you might have in case you have already some fabrics, defined some fabrics operational.
Okay. Second question is, it comes to my mind when you were talking about the delete option that you can put true or false to decide if you want Vxlan as code to delete things that are no longer in the data model. My question is, let's imagine you have but that's coming back to the brownfield stuff, no? Let's imagine you have a VRF already created on NDFC, and you don't put that VRF on the data model. It's Vxlan as code gonna delete that VRF?
Yes.
You put true? Okay.
Yes.
That was my question. Yes. I wasn't sure if we were tracking. Okay.
It's not listed. That's why I'm saying it might be tricky to implement this at the current stage on, in brownfield. Correct.
Okay. Yeah, you have to be very, very careful to not forget anything, any piece of config. Otherwise, you might delete that.
Plus, there is also some sort of state, right? That Vxlan as code is importing. Even though talking about state is not correct, I guess, because it's not the same thing as a Terraform state, but there is some sort of state in the inner processes, and I don't know how it would react to an object that you are partially defining maybe on the data model, but it's totally defined on NDFC. That's why I'm saying I would be careful. Actually, I would not implement this yet in brownfield unless I'm supported by Cisco Advanced Services, because maybe they know how to do this, or they can expedite the features that will allow you to import brownfield sites.
Okay. And that's all, Alessandro.
Okay. Perfect. Thank you for the help. So I hope you enjoyed this webinar. I hope you learned something new. I hope you got some sort of inspiration, maybe to start automating a little bit NDFC on your side. We covered pretty much everything what I wanted to cover. So remember, you have that repository available in case you want to review some of the code, in case you want to review some of the playbooks. We are already 3 minutes over, so I think it's time to close. Thank you very much for attending. I hope you enjoyed. Again, my first objective is always to let you something new, something new to learn. I hope that was the case. Thank you very much for attending. I'll see you into the next webinar in December, and have a great rest of the day.